what number does x represent? Okay, x is right here, and 1 1/3 is right here. And what I'd like you to do is assume that the distances between these hash marks are the same. Okay, so these are all the same distances. Okay, you need that to be able to solve the problem.
I started by counting all the marks, and of course there's 14, and I split it in half, and what was 7, so it didn't work. And then I just said, I bet x is 1. No, but it was close. What I did was I took 6, divided it into 6, and I got 5 6. This is your 1. And then if you divide this into thirds, you get your next whole. So you've got 1 1/3. Okay.
So let's talk about that again, the thirds. What were you doing with thirds there?
Dividing a whole into 3 parts, which was 2/6.
How did you know how did you know that was a third? How did you what was the aha moment where you got that?
The aha moment was that I was close to a whole with the x. So I started counting here to here, and then I found out that in 6 parts, 6 6, I could turn it into 2/6, which is 1/3.
Okay, so let me see if I understand your thinking, okay? And this is actually a great strategy. Are you going to abandon me, huh? That's
No,
okay. That's okay.
There, I will.
That's okay. So this is what I heard you say, and help me, okay? Because I want to build on your ideas. So what I heard you say was you wanted something in here to be 1.
Yes, I thought the x was 1.
Okay, so you let x be 1, which would be right here, right?
Right.
And then how did you sort out that? And that, by the way, is a great problem-solving strategy. Kind of like related to what we did last night. Go ahead and make a guess. Make a guess. And then work backwards or see if it makes sense. So you've made a guess. This is 1. And then what happened?
So I estimated 5 6 to be the x to be 1.
Right.
So then I figured out that it was close to the whole, so I went forward 1 to try to figure it out.
Close to the whole?
She went
Yes,
to
so-
sevens first.
Well, that's what I told him before, but I went to 6,
So,
where you have your finger.
okay, let me back. I'm still going to work off this one idea because I want to make sure I understand. Because this, to me, is at the heart of your solution. You said this was 1. Okay?
I estimated it to be 1.
You may estimate it to be 1. So then if you do that, you count backwards and you notice there's 5 spaces, right? Okay? And from there to 1 1/3, there's 3 spaces. So did you kind of come to terms with the fact that can't be 1 then? From
Yes.
somehow thinking about that?
Because when I
Why?
started explaining it, I wanted to tell you that I tried 14, then I tried 15, and I couldn't see it as clear as I did when I used the 6th.
You're talking about looking
Yes.
at all the hash marks. Okay? So in a way, these other ones don't really even give you much, right?
No.
They're kind of a distraction. In problem solving, that's something that your students need to deal with. You give them what are called distractors. This is all distractors because I didn't give you anything over here to help you work with it, right? So in a way, we could almost ignore this. What do you know? That there's, like you said, 8 spaces, right? Between 0 and 1 1/3, right? So, Paul, do you want to add, because I know you two worked on this, do you want to add to the thinking on sort of what was next there? How did you get, so if x is not equal to 1, you knew it was close, what did you do next?
I just kept plugging numbers till 6 popped up,
Okay.
and that worked right into 1 2/6, which was where 1 1/3 is.
So you guys, basically, this is what I'm hearing, you used the guess and check strategy.
Yeah.
Okay? Guess and check strategy is a very powerful problem-solving strategy. Okay? It's one that we want our students to use. Okay? Make no mistake about it. Okay? For our students to get to high school, to be at square 1 in problem solving, they've got to be willing to make guesses. What's 1 1/3 equal to in sixths?
8 6.
8 6. Okay, does that give us any hints?
Yes, that's what I was looking at. 'Cause it was
Okay.
8 lines.
Okay, so that's what you did, Amy? So you realize that if you convert 1 and 1/3, notice here, fractions, I'm just, star this, will you? Put this in your notes. Fractions give us all sorts of flexibility, much more so than decimals. Okay? So this is going to be a theme for the day. Decimals, not so great. Last night I saw you guys converting a lot of times, okay, into decimals. Decimals here, a lot of times they really don't help us think through problems. Think about the women and the men problem, 2/3, 3/4. Some of you started working with 0.6666, you know, and you're like, I don't know what to, you know, these repeating decimals. Every time I see my students start doing that, guess what I do? Like last year in 6th grade and when I work with the 7th graders, guess what I do? No, I give them more problems with repeating decimals. I just keep using fractions like 1/6, okay, 1/9, 1/11. I'll just keep 2/11. I'll just keep doing that because I want them to stop trying to use decimals all the time. Because once you see those repeating decimals, what do? You go, oh, I'm going to have to round, or right? And then you start losing stuff, right? Okay. Yeah, decimals. We need T-shirts. Yeah. Okay. Now decimals are there's points at which they can be useful. Okay, don't get me wrong. Part of what we have to learn is when they're useful and when they're not. Okay. A lot of times they're not, so we have to be careful. Yes.
So then 1 over pi as a fraction would have been 22 over 7? Or is it 1/22 over 7?
We'll get to that. Hold that thought. That's a great question. Okay. So 8/6 works here now. Jimmy, would you mind if I just share what you did, and you won't have to speak because I promise you wouldn't have to speak on this one. You had a nice thing. You said, and help me if I mess this up. You said he saw chunks of 4 chunks here, right? And he said, okay, 4 chunks of 1/3. So you've got a 1/3, right? Because it's like a chunk of 4. Another chunk, 2/3. Okay, another chunk. This has got to be 1 whole. And then you get to your 1 and 1/3. So he's working off thirds. You all were working off sixths. Okay? So then, once you get to that point, all you have to do is say, what number is exactly between, like the average of 2/3 and 1. Okay? And you could do that algebraically. Okay? So, just so you see that I'm not anti-algebra, let's do it. How would we find the number exactly between 2/3 and 1 algebraically? Well, you could take 2/3, add 1, right? And divide it by 2, right? That's just finding an average, right? You add the 2 numbers, divide by 2. You could do that, right? Okay, let's do it. Well, we're going to add fractions. We're not working with decimals. So that's going to be 2/3 plus 3/3. Do you want me to write it out? And we're going to divide by 2. So we get 5/3. 2 plus 3 is 5. Oops. Now we have to divide by 2. Which equals, and I'm sorry, there's not much space there. We all know when we divide fractions, what do we do? All right. And we are going to figure out why that works, but Lorenzo's about to shoot me right now. But hey, divide decimals, we invert and multiply, we get 5/6. So we got the answer that way. That would work. Okay? What do you think? You with me? Sort of, kind of? All right. I prefer, without having to do the algebra there, though, just to figure it out. And this is a key piece. 8 pieces, right? So what about dividing 1 and 1/3 by 8? Anybody do that? Divide 1 and 1/3 by 8. Okay. Okay. What'd you do, Brian?
I divided 8 by 4/3.
Okay, you divided 8 by... Okay. Do you want to come up and show us?
Well, I counted the spaces, and I came up with 8 spaces. And I said, oh, And the first number I got is 1 1/3, which was 4/3. I got 6. 6. Well, I knew it's 6. And I looked at the, well, if that's 1/6, and this would be 2/6, and this would be 3/6, and this would be 4/6, and it worked out. I should have done it the other way around, but
Can you show us the other way too, and then we'll compare them.
the other way would have been, I've got 4/3 numbers divided by 8 spaces, and so each slot would be 1/6.
Because I got the 1 1/3, and I said, okay, 4/3, okay? Then I multiply by 2, which is 8 over 6. Then I came over here and I put 6 over 6, and then I put what? 4 over 6, and then the in between is 5 over 6.
Okay.
And that's as simple as I can.
Yeah.
That's beautifully simple.